Welcome to Yerba Mate Talks.
Welcome. Today we have a discussion. We have Nico, the side maker, and we are talking vaccines. Thank you, Nico, for being here, for agreeing to have a chat. It's going to be relaxed. It's going to be all good. How are you? Doing well?
Yeah, I'm just trying to make sure on my live stream it's working. It is working, but it just doesn't look right. It's like too far zoomed in. Just give me one moment.
Go to the OBS and right-click on the preview screen, and then click on Fit to Screen. Right on OBS, and that should put the window matching the resolution of the screen, and that's it.
Fit to screen.
Fit to screen, yeah.
Where I don't see it.
Probably under transform, maybe. I think that's the path. I'll check on mine. 1 second. Yes, transform it. Do like a one click to select the window, and then it will give you like a red outline.
Okay.
And there, right click, transform, fit to screen.
Does that work? Okay, yeah, it looks good. Thanks, Max.
No problem. You got it.
First
Hello,
time
everyone on Nico's stream. Hope you're doing well. So we're talking vaccines, and I did ask Nico to give me some of his objections or what his thought process. So I will ask of you, please let us know what your ideas are, and then I prepared a little presentation with some data so we can discuss it. Go ahead, Nico.
Oh, try and recap what I shared with you?
Yeah, please, for the audience.
yeah, of course. So, as I had mentioned to Max, like I'm not coming into this having prepared a presentation or like a bunch of facts and stuff. When I really started looking into vaccines, it was probably 9 years ago. And so, obviously I was really heavily researching it, watching documentaries and stuff like that for a long time. And ever since then, I've been plugged into sort of the conversation. But a lot of what I believe now is just like kind of cemented in my head. I have like data sets and questions I would have for somebody like you, Max. And I'm really excited to do this because the whole time when I was researching vaccines, I'd often would want to come and share like what I was learning with people. And, vaccines, even back then, but pre-COVID was like a very touchy subject for people. And I would, both sides, I think, would get triggered really easily.
Oh, yeah.
So anyway, but if I just go off the top of my head, we can just start with, let's start with the idea that they have saved millions of lives and eradicated a whole bunch of diseases. So I've seen graphs where there were, let's say the early 1900s, there was diseases that were rampant, killing a bunch of people. And, maybe the late 1800s as well. And then all of a sudden, as living situations, sanitation improved, nutrition improved, various things were improving, these diseases were already dropping precipitously. And then there's these graphs where it shows when the vaccine came in, and it was already way at the bottom of that graph. And they say, oh, look, the vaccine gets credit for this huge drop, even though it happened at the very end when there was barely anything left of that disease going around. And I think I've seen that in various diseases. So have you seen those graphs? What do you say when you see that, or how do you interpret those?
I've seen some of that data, yes, when I was preparing my presentation for today, and it is one of the most common objections when it comes to vaccines. The most clear case is polio, because polio gets transmitted through bodily fluid, and when sanitation started getting better, polio improved. But I don't think it's like an exclusive thing. I think that the better sanitation contributed to reducing the rates of infection, and then also vaccines finish up, the either cutting off the transmission or making it so that people don't get the full brunt of the disease, which is pretty great. But yeah, I saw that, and I have a little bit of a slide prepared for that. And I think, if I may ask, a little bit of the foundation is some hesitancy towards microorganisms, bacteria and diseases being the cause, bacteria and viruses being the cause of diseases. That was something that we talked about. I mentioned that a little bit last time.
Yeah.
Our
Yeah. So as many might know, or maybe don't know in your audience, I don't know. People that were questioning and critical of vaccines, it was way popular before COVID. And then COVID happened, and a bunch of us kind of were like, hey, look, this is where they're going to try and convince adults to get kind of reincorporate adults back into a vaccine schedule, because for most adults, once you've had all your childhood vaccines, you don't really go back and get vaccines. That wasn't really normal, unless you're older and maybe you're getting the flu shot or something. But most of us aren't getting common, vaccines anymore once we're adults until COVID. Now there's like a lot. You're getting your boosters for COVID, and maybe you're throwing some other ones in there too. I don't really know. But basically during COVID, those of us that were already on top of the vaccines, kind of like critical of them, were then being exposed to these new ideas around, is illness even contagious? There was people basically going, is there even a virus here that's been identified in the case of COVID-19? And in fact, has there ever really been a virus that's been identified? And then that's a whole other kind of discussion, which I mentioned to you, Max. Like we could talk about that as well. But I will say that there are people who are critical of vaccines who don't take it that far, So it's kind of like flat Earth in that sense, where there's a lot of truthers who will say flat Earth is a psyop. Well, there are a lot of anti-vaxxers who will say that the no virus movement is a psyop and a trap, and it, they don't take it that far. I do take it that far. And we could go into that if you want. I don't really know if we should start there or not, but
on the presentation that I prepared, I go through the history of that a little bit, because it is, to my interpretation or to my brain, it is very important how the timeline of how we discovered microorganisms, and then we started seeing improvements in working within that microcosm of microorganisms. So I do have a slide prepared for that. Any other point you would like to bring up, or should I start?
I think if you have something prepared, let's go with that. Yep. And like I could go in a million different directions when it comes to vaccines or anything. So
perfect. So let me share my screen here. Window. All right. So I'm going to start with a little bit of history, just in case, and we're going to cover some background info, the early timeline, first vaccines, some innovative solutions. Oh, shoot. Never mind. Those 2 points are just from the template. So background info, microbes and pathogens. The first documented case of actual biological warfare happened in 1346 during the siege of the city of Kaffa. The Mongol armies of the Golden Horde used to load rotting cow carcasses on trebuchets, or as this painting shows, also human carcasses with trebuchets, and launch them over the city walls. And this is credited as the first case of actual biological warfare. And what they were trying to do is infect the people inside the city with the Black Plague. Yersinia pestis is the Latin name for that. And even back then, when people were removed from the biases of making money and so on, people knew that okay, these infected corpses will get you sick. That is the first connection.
So let me just pause you there, Max, because
no problem.
It's certainly possible that even in the medieval ages, they thought things were infectious that in fact were not. So the fact that they were, I mean, first of all, that sounds like terrifying too, to have rotting corpses being thrown in. Like, it was, I'm sure it was just there was a lot going on, right? I mean, maybe those infections happened, or maybe people were just freaked the fuck out because there were rotting corpses being, launched into their castle. But all I'm saying is that we don't necessarily know that they were infecting people. I've heard that the Black Plague, like, I've heard a lot of different explanations about stuff like that. Like, for example, they were also at those times using a certain way of basically, like, I'm trying to recollect, but like, imagine like in houses, they were all using whatever, some dirty source for fuel, for firewood or something. And they were inhaling all those fumes all the time. And that could cause illness on like a widespread. I mean, even we just have to understand that sometimes what could appear as a contagious disease could be some sort of collective exposure to a toxic thing. And
in general, yes. There are some particularities when it comes to toxic exposures and microorganism infections. They, for example, toxic exposures rarely show, for example, fever and so on. And when it is a toxic exposure, the removal of the patient from the toxic environment usually clears that up, unless it's an accumulation thing. But they present kind of different symptoms. And what I was going towards next is that we do have electron microscope images of, for example, this is of the Black Plague inside of the foregut of the flea, which is what transmits the Black Plague initially. And I mean, that is a direct confirmation of, the little critter. Right. And like that, you can find thousands of images of electron microscopes of different virus and so on. So
well,
go ahead.
I don't know about viruses.
Oh, yeah. This, let me 1 second. I can pull one up really quickly.
So I think when it comes to these kinds of things, though, what you would get from the other side, the no virus side, is they would say, well, how have you identified these tiny microscopic images? Because something like a virus could also be an exosome, and it could also be just cellular debris from the breakdown of cells after they die. It's much more of just a soup of all kinds of weird microorganisms and pieces of microorganisms inside the body than I think we understand. And so when they point us like this is the bacteria, like, okay, maybe you can differentiate that from the billions of other different kinds of bacteria around, maybe.
Yeah. I for example, we did cultures in high school, and once you figure it out, once you know what you're looking for, they're not hard to identify. This is, for example, very quick search, electron microscope images of the SARS-CoV-2 virus, and you see that they have maybe too small for you guys to see. Let me see. They have the distance. This is 10 micrometers. This is 2 micrometers, and so on. So we do have the ability to identify, and it is not hard when you have a lab to make cultures of this. And the other thing that we might find more relatable, there is something that you can do yourself, or anyone can do. If you buy yogurt, you can look at it under the microscope and you can see the bacteria that make yogurt. And for example, if you grab yogurt and you put it on milk, you can make more yogurt, right? If you grab a scoop and put it on a carton of milk, you can make more, because it's a bacteria that decomposes milk but makes yogurt. That's kind of an easy way to verify that. And with a very simple household microscope, you can actually verify some of these by yourself, which is actually what most of these guys that I'm going to talk about now actually did back in the 1600s starting. So the first microscopes were invented in the Netherlands around 1590 by Zacharias and Hans Janssen, father and son team of glass makers, of spectacle makers. So they figured out that with a set of different lenses, you can actually really magnify a small sample. So then Robert Hooke was the first one to observe in the microscope a hairy mold colony. And this is of course, they didn't have pictures. This is the drawing he made of what he was observing in that mold. Then on 1676, we have Antony van Leeuwenhoek, was the first one to observe oral bacteria, took a saliva sample, and we also have his drawings here, and the later images that we could take when technology improved, and they're very accurate to the representation of what oral bacteria looks like. Then Edward Jenner was the first one to produce an actual vaccine. And it's a very interesting story. This guy was trying to figure out smallpox. And what he figured out was that there is also this other illness called the cowpox. So this guy grabbed, I think it was an 11-year-old boy, and grabbed pus from the cow that had cowpox and jabbed the kid. So the kid developed very mild symptoms on the area, and they had a series of inoculations with the cowpox. And then this guy, Edward Jenner, grabbed an actual pus sample from someone who did have smallpox and gave it to the kid, and the kid did not develop the symptoms of smallpox at all. So that is the actual first documented case of a vaccine. And what it means is that if you had cowpox, you were now immune to smallpox. Louis Pasteur in the 1850s discovered that bacteria was the cause of food spoilage.
Hold on.
Yes.
Sometime, but like, do you want me to interrupt when I have like an
no
objection?
problem. Yeah,
Okay.
we can chat.
Because first of all, didn't that kid die?
No, I don't think so.
I'm pretty sure if you can look it up.
I mean, they people usually die, but not of the disease.
Well, I'll just let's say so this guy was taking cow pus and injecting it into someone's arm, and there were symptoms. So that could be a rash or something, which might make sense if your body is rejecting cow pus. And if you do that over and over, maybe you have a reaction to it. And then he infected the kid with human pus.
Smallpox, yes.
Didn't get sick. He didn't develop the here's the thing. Like, here's what throws everything to me. Just one of the biggest questions. I think I probably mentioned this to you, Max, but they did studies in the early 1900s trying to prove that the Spanish flu was contagious, and they failed in multiple studies. They couldn't get the person sick no matter what they were doing. They were having them cough into each other's mouths. They were like infusing different blood. They were doing saliva. I mean, all kinds of stuff. And the prisoners who they were experimenting on weren't developing the Spanish flu. So that, to me, why is that not talked about more? I don't know. There's like, as far as I know, there's never been contagion itself has never been proven. In fact, those ones proved that, hey, maybe it's not what we think. So the idea that he was infected with smallpox and he should have had this big reaction, no, not really. I mean, they tried to do that with the Spanish flu and they failed. So it doesn't prove to me anything except for maybe that guy had an idea that, hey, if I, like, there's a concept of like, if it's this idea that the microorganisms are trying to kill us or whatever, infect all of our cells, then yeah, maybe like we can strengthen and it's all a story that I no longer really believe anymore. But you're reinforcing like these are the building blocks of that story, but every piece of it, I'm like, I don't know about that anymore, So
wait, but we have this healthy kid gets poked with the cowpox, develops the symptoms of the cowpox, becomes
right there though.
immune.
When you say he developed the symptoms of the cowpox,
yes,
what do you mean? I mean, he again, like, so he had a rash on his arm. Like, that's not.
No, it's not a rash. Pox, you get very big pus-filled blisters, right? And that is the disease's mechanism for transmission. Because if you have in any population, let's say cows, you have pus, blisters with pus that end up blowing up. That's how the mechanism for the bacteria to spread, right?
Maybe. I mean, you could say the same thing with poison oak, but that's actually not how poison oak spreads. Poison oak is an exposure to the oil that's on the actual plant. And what blisters up and when you scratch it and it oozes out and stuff, that's not actually spreading the oil around or anything. It's not like that's going to infect you.
But that's different. It's different,
but it like there are people who believe that you will get poison oak if that ooze that comes out, and it's not. And so in your case, like maybe the smallpox escapes and through those pus, or maybe it's just your skin ejecting. I mean, that's the concept actually that these people are talking about, that basically all rashes and all boils and pimples and all that stuff is just the body trying to expel toxic waste because it's overloaded with it. That's why people that are, maybe not eating well have acne problems.
Yeah, but acne is very different than acne is just the sebaceous glands that produce the oil that we have on our skin working overtime, for example. But it is kind of fundamentally different than these types of boxes, because what you can do also is you can now take a sample of the pus and you can put it under the microscope and you will see the bacteria, because that is bacteria in itself, right? Mixed with immune system, white globules and so on, right? But we can actually verify these things. So that was the first one. But this guy got the idea from something that had been happening for about 300 years. There is documentation of people around the 7 to 1000 AD of people contracting smallpox on purpose in Arabia. There is documentation, there's historical documentation, paintings and so on, because they knew that if you catch it early, it's you fight it off way better. Like, for example, varicella, that is super rough if you get it as an adult. But if you get it as a kid, it's not that big of a deal, right? So this guy, it all comes from, understanding some things and observing and testing and so on, which is where we get the idea. Then Louis Pasteur discovered that bacteria causes food spoilage, because the main hypothesis at that time was the spontaneous generation of life. That was kind of, they thought that if you left food there, then flies and maggots appeared, and they thought that happened spontaneously. So what he did was put food below like a glass bell, and the spoilage took way longer to produce. And then the next step was Dmitry Ivanovsky discovered that there was something apart from bacteria, because they were having a problem with tobacco plants having an illness, right? The tobacco crops were having an illness, and they had developed a filter for bacteria that would eliminate bacteria. It's a fine filter that wouldn't let bacteria through, but they were taking the sap out of the infected tobacco plants, passing it through the filter, giving it to another tobacco plant, and they were still getting infected. So their reasoning is there has to be something even smaller. So Dimitri was the one that posed the idea of the virus, and I have here, yes, some other firsts when it comes to vaccines. In 1721, Lady Mary Wortley Montagu brought smallpox inoculation to Europe by asking that her two daughters be inoculated against smallpox, as she had observed the practice in Turkey. This was what I was telling you about. The people in the Middle East were already kind of having this idea that contracting the disease early was good for people to become immune later.
I mean, people still believe that today, right? With chicken pox parties, there's a lot of parents that will try to have, I mean, you were saying that too, varicella, that's chicken pox, right? So, yeah, I mean, I'm just saying it's still, people still believe that to this day. Now, whether or not, people, like I said, they might have been believing stuff like this for a long time, but that isn't necessarily proof that these things happen in the way that that they were telling.
But for example, with varicella, we can check that the actual mortality rate for children is so much lower than the mortality rate for adults. I had a friend, he caught varicella from his little brothers at 17, and he had a really hard time, and he was still not an adult. So varicella, it is way tougher on adults than it is on kids.
So, I don't know how much you know about like what the no virus position, like what do they say about things like that?
I don't really know.
They do. So basically the paradigm that they're working from is that, well, viruses, we'll set those aside for a second, but let's just say bacteria and stuff like that. Like, yeah, they're in there in the bodies, part of like a cleanup process. They eat dead and decaying tissue and stuff like that. So it's kind of like cholesterol. It's like, is cholesterol the problem in an blocked arteries or whatever, or is it the body's repair mechanisms that are there trying to put out the problem? So people talk about blaming the firemen for the fire. Like we blame cholesterol when cholesterol is kind of, the fireman. And so in the same thing with a lot of this bacteria stuff, is the bacteria itself the problem, or has the body been under some kind of assault where the bacteria, not that it's like, I mean, some people think it's just there to help or something like that, I guess. But even if it was just there to kind of clean things up. And so, if you have a healthy system, it's not going to get out of control. But in any case, a lot of things like chickenpox and stuff is when your body is overloaded, and it has to have some kind of this process, like a detox process, or even a maturation process, like maybe because people like Rudolf Steiner, I think, believed that some of these childhood illnesses were kind of part of a process of maturation for the body. And so if for some reason that didn't happen early on, whether it's a detox process or whether it's some sort of process that's the body has to go through, maybe for some reason, then if it doesn't get initiated in childhood, then it becomes a much bigger process to clean out later in life, and it can even kill people potentially. That's kind of the idea.
Let's say we managed to grow a culture of bubonic plague, and we grab this culture and we give it to a mouse or a monkey or whatever, a lab animal, right? And now that animal, which was otherwise healthy, now develops the specific disease that we have associated with that bacteria. Isn't that like hard evidence that, we have this healthy organism, we injected it with this, and now it has this disease?
Yes, but you would have to, I would be curious to see what exactly did they do. One, was it just the bacteria, or was the concoction that they created full of all kinds of cytotoxic shit in there, What was it? Was it simply like ingested or inhaled or something, or applied, or was it like injected into their brain or something? Because there's some crazy studies out there, like, look, you inject this concoction into their brain and they develop, paralysis. Well, maybe it's the bacteria, or maybe it's that you damage their brain or something.
I mean, we have different things, because we do have, for example, anesthesia that is a direct effect, or drugs. For example, you take LSD, you get the effect of LSD. That's a drug. It goes over, your body metabolizes it, and then you get high, and then you're back to normal. Mm-hmm. But it's not the same when you're doing this bacterial tests, because what you do is you put the bacteria directly into the organism. Because that's what you do when you're testing. The rigor is that, okay, we have this microorganism, we think it causes X, right? We took it out of the black pus pustule of someone with the Black Plague, and now we inject it onto this mouse. Now this mouse has the Black Plague. That is basically the way of science. If you have confounding things, like if you inject the mouse with a bunch of other stuff, then you will never know if it's exactly what you're testing for. Well, so those things are accounted in the scientific method overall.
I don't I no longer trust that. That would make sense that you isolate the bacteria and only use the bacteria. But I know that that's not how it works. At least, I mean, maybe it's different for bacteria, but let's just say I'm skeptical. Like, I'd like to see the study, and exactly what they did, because have you heard of Stefan Lanka's experiments?
No.
So one of the reasons people are out there saying I don't believe in viruses anymore is because they suppose, they claim they can't really isolate a virus because it's too small or whatever. You can't take it out of the cell and have it exist outside of the cell or something. So what they do is grow the virus on a medium where they starve the cells, they inflict them with all kinds of shit and stress them out. And, that's what they then infect and go, oh, look at the, or they're even just watching the cells die and they're like, oh, it's because of the virus. So Stefan Lanka was, or is, a virologist, if I'm not mistaken, in Germany, who has been pointing, like, basically proving that the cytotoxic effects, the cells dying and all that stuff, happens with all of the stuff they're putting onto the medium, even if you take out the so-called virus or bacteria or whatever. So that's when I say, like, you're suggesting that these things are controlled, and I don't think that's true. But I could be wrong. But I'm telling you that in some of them, it's definitely not, especially anything virus related.
But let me share this other thing for a moment. We did have limitations to actually see viruses before we actually have electron microscopes. But now that we have electron microscopes, we can actually see so much more, to the point that we've seen the structure of atoms with electron microscope, with like high-end electron microscopy. So other than like seeing the thing, I don't know how else one would be convinced. If someone is like, you can access.
Well, the reason no one would just say, "Oh, there's the viruses," is because, as I said, we're looking at something that, first of all, has already been like dried and like it's not even alive anymore. It's like already heavily processed biological material. And then on top of it, you're looking at things like circles and little fuzzy images of things that, like I said, exosome, virus, all these just cellular debris and breakdown. Like it's a freaking jungle there. And we're supposed to say, oh, see that right there? That's a virus. Well, is it? Well, maybe. But can you prove it? Or like, just because you're looking at images of these, like I said, whatever it is, cellular debris, some sort of biological things going on, doesn't mean that you've isolated it and you can name it and that you can then infect things with it. That's never been done with viruses, as far as I know.
No, but it has, because, for example, when we have identified cells, I mean, I can identify cells human cells on a microscope. It's not that hard. It just takes a couple of observations and it's trivial. So now we have a cell, a healthy cell. We know what it looks like. And now we have, for example, this. It's like, okay, what are those? What are these things? Why are they there? Right? And if you are going by the rigor of the scientific method, then you would have something to compare it to, like a healthy cell and an infected cell of the same type.
All these cells are not alive at this point, right? So when you say healthy cell,
you can keep them. Yeah, but you can keep them in cultures.
But by the time they've doing the electron microscope, my understanding is they've been heavily processed, and they're like, I'm just saying. I mean, the idea that there's a healthy cell and you can tell that there's these little things going and infecting them, like I don't think that's a story that you could say, but aren't there all kinds of things going in and out of cells all the time? And again, aren't they like, doesn't your body recycle cells on its own when they're, I mean, there's just so many things going on. Like the idea that we know exactly what those little things are based on these pictures, and there's the virus and it's infecting them and then it's going throughout the body. That's the story. But people have a lot of real questions about it for many, many reasons. Again, just the one I just shared with Stefan Lanka.
I don't know who that is, but I can definitely look him up. Here we have, I forgot that I have the details of what I was telling you about. In May 1796, English physician Edward Jenner expands on this discovery and inoculates 80-year-old James Phipps with matter collected from a cowpox sore on the hand of a milkmaid. Despite suffering a local reaction and feeling unwell for several days, Phipps made a full recovery.
Okay, so pause right there. Like, again, if I were to, if you put a cow pus into someone's arm, they're going to probably have a local reaction and they might feel a little sick because it's a foreign matter that you just put into your skin. You don't do
okay.
No one does
but
that.
If I grab a sterile needle and I poke myself, I only get the wound, right?
Yeah, I guess. Yeah. Uh-huh.
But nothing else happens to my body. Now, we grab another sterile needle, we dip it in cow pus, do the same type of motion, the same type of jab.
Mm-hmm.
And now you not only you have the wound, now you have it builds into a sore, and now you develop a fever. You get other wounds in the same source in other parts of the body. Don't you think that is fundamentally different, that there is something directly connected to that pus that is generating that result?
I would want to see you take pus from any other, like a human, pimple. Like what's the control can't just be a syringe. You're not just putting a syringe in there. You're putting all pus. I mean, pus is like the stuff that your body is trying to get rid of. It's probably carrying whatever it is that was the assault in the first place. Is it a bacteria? Maybe.
Yeah.
Maybe it's some sort of toxic shit that the cow is trying to get out of its body. And so if you take that and put it in your body's probably going to want it out too. I mean, it doesn't have to be a bacteria though. I'm just saying
we grab the pus. And let me see if I can actually find an image of cowpox microscope. And now we grab the pus and we start identifying things in the microscope, right?
Oh shoot!
and there we find.
They can't hear you, Max. I guess my live stream is going to shit. That's fine though. I'll upload this later. It's all good.
I'll forward you the video, but if you want, we can go to OBS and add the audio source right where we added the window capture. Click there and add. Let me see what the name of the option is. Audio output.
Oh shoot! Sorry, where are you again? In OBS.
In OBS.
Sources.
Where you added in sources, yes. Audio output.
Mac OS audio capture, maybe.
Yeah, that should work. Yep.
All right. Well, we turned it on.
Okay. Do you see the meter moving?
Yeah, I do see the meter moving now. I think. And wait, talk again.
Do you see
it
move?
Yeah, it looks like it's good actually. Maybe I might need to turn it down a little bit, if anything.
All right, perfect. But if you want, we'll get you the full stream so you can upload it to your channel, no problem.
Okay, thank you.
Like we did last time.
Yeah.
So we grab a sample of the pus and oh shoot, I'm not sharing the correct screen. 1 second.
Cool.
And now we see the little critter, right? The cowpox bacteria. We identify it because it's fundamentally different from other. And what we have to remember is that when we start piling up knowledge, all you need to do in most cases is like, okay, what are the components of pus, like for acne? And you can find that on a book, right? You can see what a microscope view of a healthy skin cell looks like, and so on. So we are starting to build up on knowledge that is handed down, and eventually someone goes like, is that right? And you can verify it yourself. I mean, I've seen my own blood on the microscope, and it looks exactly like what the books say, which is, a clear indication of that. So
so think about it this way. Imagine you're right, electron microscope, whatever, you can see healthy cells and they look better than infected cells. Again, though, kind of like with cholesterol, how do you know that those infected cells have been infected by a virus and it's not some other reason that they're breaking down? Like, how do we know that it's an infectious agent that's a virus? We don't, right? I mean,
well, in the cases of the original discovery of viruses, they had developed a filter that it wouldn't allow bacteria through. But the thing that was actually infecting the plants was still going through because the crops were still getting infected, right? So now we have
have
bacteria, like, and we have something else.
There is, or those tobacco plants were, I'm almost positive that there's an answer. I don't remember what it is. But there is some answer for like, well, what was happening to those tobacco plants? It might not have been a virus. Maybe it was something else.
Like what?
Like something in the soil, some sort of pesticide they were using.
This is the tobacco thing happened way before pesticides was a thing, and this was discovered by a man who was actually a botanist. So he did know what the different types of illnesses that plants get, because they present, just like humans, they present very different symptoms. For example, if you are putting too much nitrogen, the plant will maybe become brownish. But if you're putting too much phosphorus, the plant may become yellowish, right? So there are these direct symptoms of the different things. And this guy, they had tried everything, and until they actually came up with this idea, because they thought it was a bacteria, right? So they tried this filter thing, and the plants were still getting infected.
Which made them think that, okay, then we're not wrong. There's just something else that's infecting them in this.
Yeah, right? Something else, and something smaller.
Yeah.
Something smaller than bacteria, it had to be. And that's where they got the idea for the virus, which they couldn't actually confirm until many years later. It happens a lot in science that someone has an idea that at the time they don't have the technology to actually verify. It happened with relativity, it happened with a lot of these microorganism problems and so on. And that's how we go about building these things. But if you have infected sap, you run it through a bacterial filter, you know that now that sap has no bacteria. and you put it on another plant and it also gets infected, then what other conclusion can we draw? What other thing could we think that it's not that is has to be smaller than a bacteria, and that would be transmitted like that?
Yeah, I was just looking up. I was actually, ChatGPT is helpful sometimes, right? Because I'm like trying to remember what does my side say about that? And I think it is something about, maybe the filtered sap contained small tiny particles that could have been toxins or protein aggregates, blah blah blah. I don't know. Maybe maybe there is something that was actually infectious that wasn't like a toxin, but was actually whatever they think viruses are.
So let me finish up this. Like 2 months later, this guy Jenner inoculates Philip with matter from a human smallpox sore in order to test Philip's resistance, and the kid remains in perfect health, and he was now immune to smallpox because he had previously contracted cowpox, right? So this is the first person that was inoculated, and the term vaccine was taken basically from the Latin word for cow, which is vaca, right? Now, I don't know how much else we could go about proving that these microorganisms exist when we have, we have the direct confirmation of smallpox and cowpox, how they interact and how we do that. If electron microscope images, and I know that those are not for everyone, because not everyone can get access to electron microscopes, but at the very least, bacteria, you can check bacteria for yourself with, I don't know, go to a creek, grab a sample, and even with a cheap.
Yeah, I mean, I'm not denying that bacteria exist. It's just the question of, do they like infect healthy people, or are they there? Well, first of all, I mean, my understanding is that we have all sorts of bacteria in us all the time, including the ones that we're supposed to be afraid of, like E. coli and whatnot, right?
Yeah, but that's a great example. But E. coli, you can find E. coli out and about. And I mean, it would only take you just buy a white mouse and infect it. Right? I mean, that is something that you could do by yourself in your house if you really wanted to verify that.
I could isolate just E. coli in my house, or I grow it on something.
Yeah, you can grow it and then give it to a mouse, either inject it or put it in their food and so on. And
yeah, I guess that would be cool. I would just also run a control, right? Let's run whatever we're feeding them, the substance that we're growing it on or whatever. Let's feed it that too, or inject it with that too, and see if there's a difference.
Yeah, and you can get 3 mice, give one regular food, just use it as a control. That will be a healthy mouse. Give another mouse something else, and then your E. coli culture. I mean, if anyone, that is something that is pretty much accessible to anyone.
Those experiments, which maybe you've never heard of or seen the evidence for, or whatever, but like if they were trying to infect people who had this so-called Spanish flu, they were trying to infect prisoners, and they failed. And they did this multiple times, like different studies.
I would have to look at the study and ask one of my friends to help me with that, because I mean, you know how sometimes stuff fails. There's people who fail when setting up um, the Cavendish experiment to verify gravity. I mean, experiments can fail,
Sure.
but
It's just, to me, those things are way clearer than, okay, this guy, took cow pus and slightly infected a boy's arm a few times, and then, hey, exposed him to smallpox and he didn't get it. Therefore, vaccines work. Like, what, they're, it just, when I hear about these studies where they tried to prove illness was contagious and they failed over and over again, it's very concerning.
wait, doesn't that is sounding to me like a little bit of the sharpshooter fallacy, because you're counting you're putting more weight on a couple of actually failed experiments than in all of the other ones that actually do confirm that bacteria or viruses cause the infections, right?
Well, because it was more direct. They were actually just trying to prove that it was contagious. In your case with the smallpox cow blister thing, he was trying to actually prove that the kid, he was assuming that smallpox is highly contagious and that the kid should have gotten smallpox but didn't because he did this inoculation. Well,
right.
I want to establish that smallpox. Can you first prove to me? Can you give it to some kid and show me that smallpox can? You know what I mean?
But that was established long ago. I told you that even for 500 years before, people were already seeing the connection that if you saw someone with smallpox and you were hanging around them, you would probably get it yourself if you hadn't already had it. But it is something that you usually don't get twice.
That was a belief. Sure. And we've believed all kinds of things. I mean, people believe that a guy died and rose again 3 days later. They believed that 500 years ago, and they still believe it today. Some do.
Right. But we have a difference there is a direct correlation that if you are around someone who has smallpox and you haven't had it yet, and you touch them and so on, you will probably get the smallpox. So there is a direct.
It's not just a belief. Max, have you seen that? Like, why do you assume that?
Yeah, but it's a belief. It's a belief that is based on evidence. So
what's the evidence?
That if you hang around people with smallpox, you then get the smallpox.
Where has that been proven? The people believe that. They've been believing that for 500 years. That doesn't mean that they were right, though. Like, it might be that just a bunch of people got smallpox in a certain place. You do know that, like, a lot of diseases that they thought were communicable turned out to be nutritional deficiencies or some other kind of toxic exposure, right?
Do you have an example?
Yeah. I was just looking this up earlier today. I know beriberi is one of them.
Don't know what that is.
Beriberi, original belief, beriberi was thought to be an infectious disease that spread among sailors and soldiers in crowded quarters. How long did they believe that? I don't know. But at some point, it turned out to be that beriberi is a deficiency of vitamin B1. Pellagra ravaged parts of Europe and the American South and was thought to be infectious, just like smallpox. True cause, it was a vitamin B3 deficiency, not contagion. Rickets was thought to be infection in industrial cities. Is actually vitamin D deficiency. So my point is simply that, like, people have thought things were infectious and they turned out that they were not. So that would make us be very skeptical about anything. Smallpox, cow blisters, like, dude, not good enough, really, evidence-wise. For me, that's not nearly good enough.
Right, but how did we determine that we were wrong about that stuff? We did the scientific method. And now, with the scientific method, we have the case of this little kid, of Edward Jenner, James Phipps. Now, if you repeat the same process with 100 people, isn't that like way more evidence for the claim? Like if the same thing happens over and over and over, like for example, if I drop this, I know it will fall, and I can drop it until the end of time and it will continue to fall. That kind of is evidence that things fall, right? At the very least.
Here's the problem. If in my head, what could have happened here is this kid had a small local reaction to cow pus being injected into him. And then when he was injected with smallpox, maybe for some reason that didn't cause the same reaction there and he didn't get sick.
Why?
Maybe because it wasn't cow pus, it was human pus. Like, I don't really know. But cow pus is more of a foreign substance than human pus. I know that. So, and maybe they weren't even worried about maybe he had a small reaction and they kind of overlooked it because they were just looking for the major smallpox symptoms and it didn't happen. Well, that could just mean that smallpox wasn't contagious. If you did this 100 times and smallpox isn't actually contagious in that way, then it could have been repeated 100 times. And it doesn't mean that it's happening in the way that you think it's happening or that he thought it was happening. Like,
right, but
maybe
all of those things.
What I want to see is actual proof that you've been able to infect somebody with smallpox before you claim that you've prevented prevented it from happening. Like, where do we see, they were launching people into a castle. Okay, did that work? Because I've also heard that the colonists like laced, right, the blankets in America with smallpox, right? Isn't that also a claim? But and were Native Americans dying of smallpox? Yeah, I think they were. But again, they were also, their whole entire world was being destroyed. Their food sources were being destroyed. They were like under assault. And I'm pretty sure that they also thought that these things were infectious, probably because we told them that they were. And so that when people had the smallpox, people stayed far away from them. And a lot of times I think they just died from like dehydration and neglect, basically. But anyway.
Right, but it's a lot of appealing, could have been this, could have been that, but we have a direct link through the scientific method of, okay, if you grab the pus from this person that has smallpox and you put it into a healthy person, now this person has smallpox.
Wait, we have that?
Yeah.
That you didn't show that part. When did that happen?
Hold on. Where am I here? Smallpox contagion. One second. I think smallpox is one of the best cases because it only transmits directly from human to human and with very close proximity. And it doesn't cross to other animals. So here we go. Scabs and the fluid found in the patient's swords also contain the variola virus, and the virus can spread through these materials or objects. Like, so if you pass on something and someone then touches them and so on, they can actually get it. So yeah, we do have those.
But that's the story right there. That's the story.
Right, but why is the story there? It's because there is a study behind it. Right. I mean, yeah, but they don't just invent stuff and they write. They do actual controls of these things.
They don't though. That's what I'm telling you, man. Look up Stefan
Okay.
Lonken's experiment. Like maybe they do sometimes. I would hope so. But in the
What is
case
the
of
name of that person?
stay with an F, I think. FAN.
Yeah.
Space LANKA.
Stefan virus. Okay, I won't.
I mean,
I'll save
most
this
of
for later. But
yeah, most of the no virus people are basically just simply asking for proof for like a true control, essentially. Because the thing with viruses, they can't like with bacteria, you do that spin thing, right? And you can separate the things out, and you can actually purify the bacterium. Viruses, they can't do that, is what they say, and
okay,
there
but
is no way to.
This guy has the first paper that I'm seeing here. We describe a procedure for the isolation of virus particles from the marine brown alga Ectocarpus siliclosus. Virus particles are composed of at least
Yeah, that's
13
from
different.
1993, though. I mean, that's what I'm saying. This guy is a virologist. Like, he believed all of your things. And then what is he saying now in 2025? Oh, it turns out that we don't actually know that viruses do what they think we thought they do, because we can't, like I said, man, he made a control experiment, and guess what? The cells still died without the virus in them, which just throws the whole thing. It's kind of like the idea that you try to prove contagion and then you fail. It's like, oh shit, well, maybe contagion isn't actually what's going on, at least not as simply as we have thought. And yeah, I mean,
I don't
he's
know
been
if you
going
could
back and
find me
forth.
one of those. If you could find me one of those citations, because as far as I can see here, this guy works with viruses.
No, so I'm saying he definitely did. Why don't you go Stefan Lanka and then say control, the virus control or something? He was
fined 100,000 euros. Is this the guy?
Yeah, but I think he probably appealed that and then won. I think, I don't think he actually had to pay that, actually. So, could be wrong.
It's blocked. But yeah, it looks like this.
He's been in court, but I think that he eventually won. Could be wrong. But I mean, I'm talking like in the last year or two, he's been putting things together, proving that there is no true control in any of the virology studies, and that the cells die simply because you're infecting them with all the other stuff in cow pus, for example. Like, you're starving the cells, you're doing this, you're doing that, and yeah, they will, like, the same effects happened with or without the so-called virus in there.
Mm-hmm. Okay, it looks like I found this. Dismantling the virus theory. I think I found it. I'll have to read it later.
Yeah, even that, what's the date on that?
2015.
Even that down there, is there any date on that thing? Is that all the same thing? It's just
Yeah,
I mean, that's 10 years ago. I'm still thinking that's probably outdated. We're talking like cutting edge,
I mean, I'm willing to put a pin in it. So if you can get me like what you might have seen, I'm willing to take a look at it later.
Yeah.
No problem.
But I'm not like, I know I might be wrong, right? Maybe, I mean, we might be wrong. Maybe there are some illnesses that are contagious. But there are reasons why I'm highly skeptical of that. And and I mean, 3 of them I've already shared with you. 1, we thought that illnesses were contagious that turned out not to be. 2,
Yeah.
they tried to infect people with the Spanish flu in multiple different studies and weren't able to. 3, it turns out that so-called, scientific experiments proving that the viruses are doing shit don't even have real controls. That like when you actually, again, like just take any cells through the same process, the same thing happens with or without the virus. Like those 3 things alone. I mean, not to mention the fact that, we're talking like it's an $80 billion a year industry, vaccines. Like there's reasons we like there's a lot on the line here. And that's assuming that, 80
You would
billion
make way more money selling caskets, though.
No way, dude. What are you talking about?
Yeah.
You're talking.
I mean, if you had
80
people dying left and right, you could also make pretty much the same money selling caskets. And again, that's why I went so far back to the beginnings of this.
I don't even know what you mean, though.
Because
What do you
these people didn't even care about the money. They saw a problem. This is like true scientific endeavor. These people weren't after fame or glory. They were just wonder that
Louis Pasteur. I mean, I would.
He saw people dying from or getting sick.
There's a lot of people who will
stuff.
say that guy plagiarized. What's his name? The other main guy. I mean, there's the guy that had the whole different view on bacteria, and the medical system went with Pasteur because they could make it profitable. The guy, what's his name? Béchamp? Belch.
No idea.
Béchamp, I think. But yeah, man, see, the problem is there's a lot more to there's more to these stories than meets the eye. Like Louis Pasteur was a fraud. I mean, that's what some people say, including I think one of his own descendants published his journals against his wishes. But I mean, he plagiarized work and like fudged a bunch of stuff. And I don't know, like I'm just picking one of those guys, but I think that in any case, at a certain point, the whole medical system depends on illness being contagious. I mean, that's one of the foundational concepts. And again, like, vaccines, people like yourself think of like saved millions or more, like maybe of lives, and maybe they haven't. And maybe they've just, in fact, not only are they making money off of the vaccines themselves by the billions, and these are companies that pay billions of dollars in fines for being corrupt, right? It's not like we can just trust these companies. They literally pay billions of dollars in fines, the vaccine manufacturers, and penalties for other shit. They have no liability since the 1980s. There have been $5 billion given out in the National Vaccine Injury Court. I'm just saying there's and not only that, but if the vaccines do what we think they do, which is basically just poison kids, then they don't. That's
the next part. We can go into that.
Well, all the chronic disease that ensues from that, guess who profits from that? The same companies. They're actually making way more.
But there is no study that shows that vaccines cause any kind of that. Because what they do is they basically use the body's own immune system to work to the way they work. The way vaccines work is that they take what's there, the human immune system, and they make it better. It's like someone telling you, okay, that guy is going to come and punch you, right? And then the guy comes and tries to punch you, and you're already aware, like, oh yeah, the punch is coming, and I can move out of the way, right? So that's what they do. But actually
that's
prepared
the story that you think that they do, but they admit that they poison you, because how else do they get you to mount the response? That's why aluminum is in there. That's why, the adjuvants. What are the adjuvants in there for?
Yes, that is adjuvants. What they do is it's not poison, because the definition of poison is something very different. You can say it's a foreign thing, whatever. But what the adjuvant does, it puts your immune system in a little bit of an overdrive. So what they do typically, and this is from the 1920s, when we still were vaccines, the main technology of vaccines is injecting attenuated microorganisms like the bacteria, very weakened, so that you can create the antibodies for it. And the adjuvant, what the adjuvant does is it throws your body into that state of into high alert, right? And now you said the other important piece of information, and I prepared, I think I can illustrate why that conception is wrong. Because adjuvants, it's incorrect to say that they have aluminum. And I will explain it this way. Table salt, right? Sodium chloride, correct? Innocuous, actually indispensable to life. Like we couldn't live without salt. It's we need it for our normal functioning of our body. Now, sodium chloride is composed by two very heavily toxic elements. Sodium is a metal that literally ignites on fire when in contact with water. To keep sodium metal stable, you have to keep it submerged in oil, because as soon as it has any contact with water vapor, it ignites with the air. Like even with humid air, it just ignites, right? Then we have chlorine, also extremely toxic. Drinking chlorine by accident causes a lot of problems, and people have been hurt. There's like infinite medical cases of people drinking bleach accidentally and having a really hard time. The wonderful thing about chemistry is that you have these very toxic things, sodium and chloride. Now they're combined, and it becomes an indispensable element to life. So adjuvants do have aluminum or mercury, but they are not the elemental mercury or the elemental aluminum. They are salts, basically, right? It happens the same thing. So you have something toxic, and now we have this sodium chloride, which is a combination of two toxic things that now create common salt, right? And the compound is not only non-toxic in small doses, it's indispensable. Right?
Well, I don't even agree with that, actually.
That is not an agreeable fact.
No, sorry, Max, but you don't have to eat salt to survive, actually.
You do. You actually do.
No, you don't, man. There's civilizations that don't eat salt. There's tribal communities that don't eat salt. You get the sodium from the food. You get the chloride or whatever from the food. Those things you don't eat them isolated. Like that's a laboratory thing. Maybe they're toxic in that way, but you don't need to have salt. In fact,
no, you do. It's indispensable to life.
No,
elephants will do 400 kilometers just to go to the salt fields, and they lick salt.
Okay.
And even if you
let me clarify, humans don't need salt like that. Maybe maybe herbivores. I think it's been shown that herbivores have to do that, and maybe carnivores might lick salt, because guess what? It has those things that we need, and sometimes just like for us, licking salt, having a little salt can make it taste better, but you don't need salt.
No, you do. You do, because it's what regulates osmotic pressure inside of the cell.
Max, your body can create it. Maybe you need it internally.
No, we can't.
I promise you're wrong on this one, man. You're wrong on this one.
We cannot create salt.
I don't even eat salt myself for a lot of the time because I eat raw meat. I don't put salt on the raw meat.
Right, but you are eating an animal that ate. They do have sodium chloride in the meat.
Yeah, that's what I'm saying, man. It's within things. Sure, it's within the
Right.
food. It's within the
Yeah,
food.
yeah. We add salt extra for taste. So let's discard that. I'm not talking about what the extra that we add for taste, but there is a minimum indispensable amount of salt that we need so that the body can function properly.
I could be wrong, but I don't know that meat has sodium chloride in it. It has sodium in it. Is it in the form of sodium chloride?
Yeah.
I mean, we're
Yeah,
debating
you
something
couldn't
that
have sodium. You couldn't have sodium alone because sodium alone elementally it's a metal. And as I told you, elemental sodium ignites with any kind of moisture H2O. It just lights up on fire.
Okay, but isn't there other forms of sodium? I mean, in food, doesn't it?
Yeah, sure. Sure, but other forms of sodium don't like what we need specifically is sodium chloride. That is what regulates osmotic pressure. The differences in salt between the outside of the cell and the inside of the cell is what conduces things from one side to the other. You know what osmosis means, right?
You're saying that we need salt for some sort of cellular process. Is that what you're saying?
Yeah.
Okay, and I'm just
Salt and,
like I said,
sodium chloride and other salts.
I think we use sodium chloride in our stomachs too, if I'm not mistaken.
No, that's hydrochloric acid.
But okay,
Fundamentally different thing. Acid and a salt, different.
Maybe I'm thinking I'm going there because is the hydrochloric acid is maybe derived from the chloride part of it, you know? Maybe
no, it has two of the same compounds, but what is lovely about chemistry is that when you add let me double check. I think NaClOH is the formula for hydrochloric acid, but let me double check because I might be missing hydrochloric acid formula. Okay, so hydrochloric acid is one hydrogen and one chloride, right?
Sure.
And it is kind of fundamentally different chemically from both chlorine, the element, and sodium chloride. You can actually, if you know what you're doing, you can start with sodium chloride and do a chemical process so that you can separate and then create potentially. I mean, we could look up the redox.
I was just saying that because I remember I think in some nutrition things, somebody's saying that salt's important because it helps you create hydrochloric acid, and that's kind of why I said that. But anyway, it doesn't really matter. The point is, look, the natural sodium in meat is mostly ionic sodium bound to other molecules. Some sodium chloride is present naturally, but most of it is tied up in other ionic forms: phosphate, bicarbonate, lactate.
And we break that down because there's a lot of chemical reactions happening all the time in our bodies.
I know, but look at you. I was just taking issue with your analogy here because you're saying sodium is toxic, but salt is indispensable for life. Well, no, that's not true. Sodium you can get.
It is. I'm sorry. Whatever. It's okay. Don't think about the indispensable part. It is, but don't think about that. What I'm trying to point out here is that we start from two very toxic things, and then you get something as innocuous as table salt, right? That's the part that people that have problems with the adjuvants don't understand, that they are fundamentally different compounds.
Okay.
Like you could literally not eat sodium metal because as soon as it touched your saliva, it would just light on fire inside of your mouth.
So first of all, you know for a fact that these things don't accumulate in the body or the brain and stuff like that. The mercury,
stuff like what?
The adjuvants, the aluminum.
Yeah, there's tons of studies. Yes.
So as we see aluminum in the blood going up and across civilization or whatever, we're getting that from everywhere else but vaccines.
No, yeah, there is, like, you can find aluminum in breast milk. That there is a minimum amount of, like, our blood, for example, has traces amount of gold, which are innocuous. Like they don't really do anything.
So if we're using these adjuvants, you're saying that they put the immune system into some sort of hyperdrive, but they're not toxic?
Yeah.
They just have a magical property that happens to work for us with the...
Not magical, chemical. Like, for example, when you take LSD, you have visual hallucinations. That is not magic. That is chemistry.
I know, but you're saying that, they put these things in here and they just happen to do exactly what they want. They're not toxic, but they trick the immune system into mounting a response. Is that essentially?
Yeah, pretty much. Yeah. The same way that an LSD tricks your brain into hallucinating.
Okay. All right.
Yeah, I mean, that is, I love chemistry. And I think that this analogy of the sodium and chloride kind of really explains what the objection of the adjuvants, because you can have something that, like, elemental mercury, what used to be in thermometers, that is highly toxic. So if you eat that, you will have a really bad time. And also, even if you inhale vaporized mercury, elemental mercury, that can also give you Mad Hatter disease. You basically go crazy, right? Now, when you have just the one molecule of mercury attached to something else, so that it is a mercury salt, then that becomes a whole different thing. The toxic parts do stop applying because the compound becomes fundamentally different, and it's a lovely, it's an awesome part of chemistry.
Okay.
Have you ever done drugs? Right. So you take the LSD and you get the hit, right? That happens every time. Every time you might get a different like a different hallucination, but the basic effect is the same. When you take, for example, antacid, because you feel fire in your esophagus, every time you feel that, you take the antacid. That's basic chemistry, and it's one of the most reliable things. Like, chemistry and physics are almost indisputable. Right.
I'm not exactly like disagreeing with you on that. It's just that I don't believe that these adjuvants, if they're making the immune system mount a response, are like, the reason they're doing that is because the body is under assault from them or wants them out or whatever. It's like any other toxic thing. It would be, and the thing is, even in your analogy here, let alone the other problems I have with it, at the end of the day, sodium, chlorine, those are toxic. Okay, so is aluminum and mercury. Yeah. But then you have, sodium and chlorine, chlorine, you put them together, they make salt, and that's good for the body. Well, it's not like, you're not saying that aluminum or mercury salts are good for the body or needed by the body, right? So it's not exactly a perfect analogy anyway. But I see your point. Your point is that, look, we can change the initial toxic things and turn them into these things that are either indispensable to life or at least innocuous.
Right.
That's the point.
Yeah.
So okay, I don't believe that that's what's happening, but I understand your argument here. The reason the reason that I think that their adjuvants are bad is because I don't think the viruses or the bacteria are even really an issue. So that is what's in the vaccine that's actually giving people the chronic illnesses, that the autism, that's what causes people to regress. That's what the parents see. They get overloaded with vaccines. Like, what else is going to, it's obvious whatever's in there is obviously.
What else? It's genetics.
There's like the preservatives, there's the adjuvants, there's the whatever modified virus or bacteria.
Yeah, we eat preservatives in canned food. Sodium is a preservative.
Yeah, I mean, at the end of the day, whatever it is, I mean, I guess we're going to get into that, right? Is it having is it having an effect on people's health that's largely negative? And that's
it's actually positive.
Well, I mean, at the end of the day, Max, like
autism
you would think that
a genetic thing.
Like, we should be able to figure this out as humans, right? It's either good for us or it's not. We didn't though. Why is the anti-vax movement growing? You think is it like flat Earth or something where they're just totally off the wall? People are latching onto it.
Yep.
It's not the same though, because it's like parents who believed in vaccines take their kid, they get vaccinated, and then they regress. They get a fever, and then they're
never happened. That hasn't happened once.
Well, how do you, like that? That is complete denial of the anecdotes that are happening, probably by the hundreds of thousands, all across the world.
That's what I'm telling you. Those anecdotes, those are not happening. That has never happened ever. Because
claim.
Autism is a genetic disease. Either
according to who?
According to the studies.
Okay, go on.
According to the studies, autism is pretty much determined from the moment that the sperm enters the egg. When you get the genetic code made for the person, that's it. That's when someone is determined whether they have Down syndrome, whether they're autistic, or have any other plethora of genetic diseases.
Sometimes you're born with things like that. Sometimes kids are making eye contact, they're verbal, then they get vaccinated, they get a fever and they get ill. Sometimes they die, sometimes they regress, no longer can make eye contact, no longer are verbal. And for you to just say that never happens, Max, that's the exact. It's like it's basically a flat earther denying evidence. It's the same thing, man.
No, it's the other way around. We have flat earthers claiming that the Earth is flat, aka this kid had autism, but it's not controlled in any setting. It has never happened in a single actual reputable study of the topic. So it's actually the other way around.
What these studies that you think prove that autism is not caused by vaccines or whatever, I know those studies. I know the common critical analysis of them, which is that one, they're basically never long-term studies. Two, they don't actually use a control. They will often use the adjuvants and all the other stuff in a vaccine, or they'll use a different vaccine as the placebo. It's not, they don't actually use placebos. Just, an inert substance or whatever. Like the let alone, by the way, all the vaccine schedule together, comparing a population of no vaccines to all the vaccines and follow them for a couple decades. I mean, those have, like I mentioned to you, they've kind of been done unofficially, maybe not to the rigor that we would like, but that's because the retort, I guess, is that it's not ethical to run those studies because vaccines are so miraculous, right?
No, not miraculous, just important. But I am detecting a little bit of a double standard because you're pretty much demanding perfection from our side of the studies, while you acknowledge that the opposing side has bad studies, right? Do you see that?
You mean when I said unofficial or whatever?
Yeah.
Like, well, I'm not necessarily saying they're bad. I'm just saying like that it's the you know, a study that would be published in a journal or whatever is going to require a lot of money, and there aren't people out there, you know, there's no incentive for people to prove that vaccines don't work other than, you know, out of trying to save people from the effects. But the money just isn't there in the same way. So you have people like that one doctor who I was telling you about. I mean, he has his own patient base, and he can tell the differences between those who got fully vaccinated and those who got no vaccines and those who got delayed or only some of them. And he can see the own data right there in his own practice. And I'm pretty sure there's something that just came out like within weeks that supposedly is one of these studies, which again shows that, you know, vaccinated individuals have way more higher, and we're not just talking about autism, we're talking about all the chronic illnesses. Like
all of the chronic illnesses, that is a wide range of stuff.
I mean, the point is that like it's all over the board. It's because if you think about it as just these vaccines are toxic and they interfere with natural processes in the body, and we're all going to have our different weak spots.
Okay, hold on, because now toxic and what you said after the effects, those are doing a lot of heavy lifting. You know that water is toxic, right? Water can be toxic. I think we need to define some terms. You know that if you drink a lot of water, you can just die.
Sure.
Correct? Mm-hmm. From water toxicity. Basically, you get cellular drowning. Apple seeds have, it's either arsenic or cyanide. But you can eat a full apple, you can eat the apple to the core and nothing will happen to you. So toxicity is a very wide term, but there are some minimum doses to toxicity. So something would be innocuous, like salt, for example. You can eat a pinch of salt, nothing will happen to you other than you getting a little bit thirsty, right? You chug, let's say you eat a whole bag of salt and you might start having some actual toxicity problems. Do we agree on that?
Yeah.
Okay. So when we're saying these things are toxic, I think we need to kind of define that properly, because the way the adjuvants have been discovered and developed, you can define it as toxic in the broad sense, but they act specifically as intended. Like, for example, when you take something for your fever, your fever goes down. You could say, oh, that is toxic, but it is an intended toxicity, right? You take LSD, you hallucinate, that's an intended toxicity.
That's an intended toxicity. But the fever, you're not trying to, it's not about the toxicity. It's about relieving the fever, which actually isn't even good for you, it turns out. But that's not, you know,
I mean, it is the body's common response. The problem is that high temperatures in the brain can like literally kill you.
Yeah, but you know, how often does that happen? Is probably extremely rare. And meanwhile, the more that you suppress things like a fever, you're just going to have cancer later on. That's the way that I look at it based on all of my studying, because your body, again, it's all these things are detox processes. Whether or not like there is some sort of communicable, like there is something like that happening, maybe. But for the most part, like fevers, snot, coughing, it's your body trying to deal with an overload of shit that it's trying to get out, in my opinion. And the more that you suppress
Sure.
that by taking over the counter medications, the worse off you're going to be. Because, yeah, you can stop yourself from having a fever or from coughing, but you're not getting out those things. They'll just get lodged into a tumor or something, and you'll have cancer later on. I mean, it's not,
I would love to see a study for that. But there are two things here that we should actually consider. When someone is sick, there are two effects. We have the body reacting. And then, for example, when you get a runny nose from the common cold, that is just the illness manifesting its own evolutionary system so that it can spread more. Because if you are sneezing around and you're the common cold virus reproduces so much that it's in your mucus, when you sneeze, you just spread the virus around. So we do have some things are the body reacting, and we have other things that are the intended causes of the disease, like in the pustules when we're talking about poxes, or when you have a runny nose from having a cold.
They're both just stories, though. One of them's probably accurate, or maybe both are, but yours is just a story, man. It's like maybe we get runny nose because the virus is trying to replicate and we're coughing so we can infect other people around us. We also cough when we smoke, when we inhale smoke. I mean, we also get snot when we're, maybe after like being in the ocean or something. Like
in the ocean, because the salt.
So
yeah,
the idea that
more than one
sometimes
thing
it's
can
the
happen.
virus tapping into your own mechanism like that's a story. Sure, that sounds nice and fits the whole paradigm that you have, but it's just a story. I don't believe that.
So you don't see the parallels with the flat earth deconversion right now? Because you know how they used to say whenever I show them how to measure the curve from the ground, that is it's like we always get the same response. Oh yeah, that's just a story. But it's not really. It's really, you're directly measuring the curve. So with the way
that's what I mean when I like was trying to impress upon you and anybody really that thinks that I'm just like, I've latched onto any conspiracy theories and they're all crazy. In flat Earth, there aren't really the so-called scientists or whatever. Like flat Earth has to deny most of the science. I grant that.
Mm-hmm.
But when you flip over into vaccines, like there's tons and tons of scientists and doctors and nurses who are against this stuff. And the science, the more you look into it, they're heavily debated for good reason. It's not the same.
They're not heavily debated. There are some, like there's a handful of people within the medical field that don't agree, and they don't have studies, or they have studies which are like not up to the point of to the level of the accumulation of the other studies.
The studies that have probably all been funded by the pharmaceutical companies that profit $80 billion a year from these things and have no liability and have paid tens of billions of dollars in penalties for other drugs, for lying about other drugs. We just have to like keep things into perspective.
Yeah,
here.
And Volkswagen has had lawsuits because they built crappy cars and they didn't recall them and they were a security hazard. I mean, that is just a bad argument overall.
No, but like Volkswagen, people buy cars because you need cars. You drive around in cars.
Yeah.
The idea that we're all mandated to get vaccines, whether you're healthy, whether you're sick, kids don't even have basically any sort of bodily autonomy in that sense where they're,
They do.
they might.
They
Huh?
do. It's just that because they are under the responsibility of their parents, they have a medical proxy that overrides their bodily autonomy. But they do have bodily autonomy.
I don't know what you mean. They're forced to get the vaccines, right?
They're not. But the one that makes the decision is the medical proxy, which is their parents.
Sure. Okay. Yeah. But I'm just saying that, like, it's not the same as a car. Like you go out and you buy a car because you're going to drive around. These things are mandated for every man and woman in society, 80 times before they're 18 or whatever. I mean, it's just saying, like, there should be a higher level of scrutiny for vaccine manufacturers than
there is.
I mean, they don't even have liability. They don't have to have real placebos in their studies. Have you addressed that? Like, how the fuck do we not have real placebos?
They do.
That are inert substances.
That is what a double-blind study is.
A double-blind study just means that the participants, whatever, the subjects and the doctors administering them both don't know who's getting what, right?
Yeah.
That doesn't have anything to do with
who's getting what? What does that imply? That some people are getting the medicine and some people are not.
Well,
that's exactly what that means.
That's what it's supposed to mean, Max. But if the placebos are just other vaccines that are already approved on the schedule, or if they're everything in the vaccine except for the virus,
that's not.
Yeah, it is. You
don't because you don't cross test vaccines at the same time. When we're testing for one thing, what good would it be to input another chemical? No, you have what you're testing, this compound, and then you have a non-compound, just basically salt water or just water. That would be great, Max. That's not actually what's happening. And the thing is, man, you don't you don't want to believe it, because the whole thing is, it would start to crumble if you started to look into these things. If there was if you think that there are placebos in all these studies, like true placebos. Yes. And that's what double blind means.
No, we just established what double blind means.
Yes.
Double blind.
You said it yourself. You acknowledge double blind means that the doctors and the patients are both blind to whether who is getting the actual medicine and who's getting the placebo. Yeah. Key word there is placebo. And how do you define that? Is it actual inert substance, salt water, like you said? No, it's not. Yes, it is. That's not how these studies are done, as far as I know. And, I guess it's something we'll both have to look into some more. But I'm telling you that, like, the anti-vax people, they ask for studies like that, and they don't exist. They do exist. I can give you, I don't have it ready right now, but I can get you a list. I can get you a list of those studies, and I can get you a list of the counter studies, the ones that the anti-vaxxers reflect, and the refutations of those. So what about, you don't think it's important to, like, establish if vaccines are overall helping or hurting somebody by having a population that has fully been vaccinated versus one that has no vaccines, and to compare those over, like, decades? You don't think that's important? Or, like, why isn't that done? Okay, and who gets to choose how do we decide who gets the life-saving vaccines and who gets left out there to dry? That is
Just
highly unethical.
volunteer. Just volunteer. I'm telling you, man, there might even be millions of people who are not vaccinating their kids at this point. Like, you think it's going to be that hard to find? Like, no, there's no way. It wouldn't be that hard at all. And people are doing these studies, just like I said, like it's not like they have the millions of dollars behind them that, most studies that are published in these journals have. But when they do the studies, I mean, you could say, well, maybe the people that are anti-vaxxers are just generally more into health. And so, that could be confounding the results. Like that's like the one thing I guess you could say. But
I knew the funding was going to be an issue. That's why I went so far back. Because in the 1800s, there wasn't the same economic incentive as there is today.
Yeah, it's just kind of a small point, the funding. It's just my point
but
is,
you keep
like,
going back to it. That's why it doesn't seem like it's a small point when you keep going back to the funding.
I'm
bringing
it. I'm bringing it there for two reasons. One, we should be highly skeptical of vaccines, especially if there's this much of a controversy around it. It's not like flat Earth or something. Like, people wake up to the vaccine thing after their own families are harmed. I mean, you can pretend like it's not happening, but that's requires you to deny like literally hundreds of thousands of anecdotes. And it's not like these parents.
What good is an anecdote when we have people that not too long ago, like a couple of weeks ago, we had tons of anecdotes of people going on the internet saying that the rapture was coming because they had a vision. Anecdotes are not good evidence. If you would bring me the anecdote and a study attached to the anecdote, that would be way better.
So how do you, like, you acknowledge that there are sometimes people die and get paralyzed and whatever from vaccines, right? Obviously that happens sometimes.
There are every once in a while you get someone that has a deathly allergy to peanuts. Yes, there are anomalies, sure.
You just think they're extremely rare?
Yeah.
Okay.
And I think that if we care about the human race as a whole, it has been a net positive. If you have someone, and I'm sorry that I have to put a number to this because it's horrible. It would be the best that nothing happened. But if you save 999,999 people, but you have one that has a deathly allergy to the vaccine or to something on the vaccine and dies, that is a very high percentage of success. And it's an unfortunate consequence that we should strive to keep it to a minimum, to, I don't know, maybe identify it previously, whatever. But I think that is a great percentage. Don't you think that that's the case?
Yeah. I think that is what one of the defenses of the vaccine thing. Like, yeah, maybe it happens sometimes, but it's for the greater good, right? Or whatever. And
right.
That's plausible. I mean, at a certain point, then yeah, I guess if it was saving that many lives, but and it was really that rare, and it wasn't like it was knocking everybody. Like, I believe it's just knocking everybody's health and IQ down, and that's part of the reason why they do it, is just to keep humans a little, their society a little bit weaker, a little bit iller. They profit off of that, and also people are just, dealing with their own stuff so much that they can't rise up or whatever.
All right. We've been going for about 2 hours. I need to take a short toilet break, and I didn't see many questions, but I wasn't paying much attention to the chat before. So guys, while we are on while I'm going to the toilet, please tag me or send super chats with those questions. And people on Nico's side, if they have any questions for me, you may do so. I'll be right back. Can you entertain the people for a moment, Nico?
Yeah. I'll look at my live chat, which looks like it has 2 people in it maybe right now. I don't really have an audience. It's okay. Sorry for can't hear Max. Sorry about that. Shirai, I'm reading your stuff here. Okay, so I'm assuming there's audience out there on Max's side. So I'll tell you what this comment in here is saying. This person's saying, not really versed in the adjuvant arguments, although I am curious as to how exactly they help attenuate the virus. Not even sure that's exactly what they do, Shirai. When they use relative risk reduction instead of actual risk reduction, that this is called fraud. I know what you mean by that. Actual risk reduction less than 1%, relative risk reduction 95%. Oh, yeah, I know what you're saying there. They use shady math for efficacy. Motorcycle helmets save your skull if you're in an accident. More likely to crash if helmet restricts your hearing and vision. Not sure what you mean there. They compared COVID shots versus placebo. Both were 95% relative risk reduction, both less than 1% actual risk reduction. You were talking about safety certifications. So those are the comments I have in my chat here.
Okay, I'm back. Sorry.
All good?
Yes, yeah, we're all good. I wasn't hearing because I forgot to turn on my speaker so I could hear from the toilet. Do you want to ask those questions? What the?
Not really. Let's go with your questions. Or is there any on your side?
Let me check. We have Max for $5 Singaporean. Not a question, but quote. I'm telling you this with no evidence whatsoever, but you just don't want to believe it.
Yeah, as he's talking about the parents.
No, he's kind of reducing your position.
Okay. I mean, I didn't come here prepared with any studies.
No, it's okay. Don't worry.
I'm just letting that guy know. Like, I don't even know what you mean, man.
Hold on. We got one more here. Not a question again. Tell him that kids, until they are 18, produce in their body far more formaldehyde out of methanol, out of ripe greens and fruits that they can get from vaccination.
Okay. Well, here's the thing what I would say on that. There's a difference between ingesting something and injecting something. We have ways to deal with... Wait, is that what... She's saying that it's naturally produced inside the body?
Yeah.
Or he was saying that? Whoever said that?
Yep.
Okay. Well, that's okay. I mean, maybe it's not the formaldehyde then that's causing all these problems. But clearly something's in the vaccine that, again, I mean, whether you're talking about all of the anecdotes out there and more happening all the time, that's how most people who are anti-vax, again, have had it happen into their own children. I don't know about most people, but a large percentage of them come to be anti-vax through their own experience like that. Mm-hmm. So and then there again is the studies showing that chronic illness is higher in the vaccinated populations. Now, becomes, I guess, a study war. Is this, but again, it's like, shouldn't that be well documented? Like, shouldn't that study have already happened? And like Max, you were saying, well, who's going to sign up to not get the life-saving treatment? Well, I'm telling you, millions of people Like we have got plenty of people.
There are meta studies, and recently Professor Dave did a great video on debunking RFK, and there was also a debate on a channel called Pangburn with two of the biggest anti-vax proponents. One of them was a doctor. He lost his license, and it's a great watch. I'll pull up those links and share them.
I mean,
over to you
honestly,
and to
Max,
other people.
Professor Dave, I can't stand that guy. I don't know. Like,
I get that. I understand that.
that guy is not. He's not
abrasive. Yeah, and it's not for everyone.
And he's just wrong too. But you know, we could. But yeah, it's beyond being wrong. It's like the way that he's abrasive. I guess you could say.
I understand that might not be for everyone, but there's other people.
I'm trying to listen to people. You know, maybe I am. You know, that's why I'm here with you too, Max. I think this is great. You know, we have to get out of our own echo chambers. That's how flat Earth has gotten as far as it did, is because people just were in their own echo chambers. And then when you did see a debate, it was from a prick like fucking Professor Dave. Like, it would have been nice to see some debates with people who were like not abrasive like that.
Mm-hmm. No, I understand that. I understand that it's not for everyone, but I fortunately have the ability to separate, you know, the argument, the actual info from the communicator. But
yeah, I reject both in that case. It's kind of hard.
Fair enough. But we're going into a little bit of genetic fallacy territory. But it's okay. We have a couple more questions from the audience. Basal Problem for $10 says, Signmaker was a flat earther. An incorrect worldview. Let's not insult people. Let's not insult him. He's been super nice, super kind. Let's don't do that.
It's okay.
What makes him think he can discern questions related to virology or immunology?
See, you have to remember that flat Earth was one of the last things that I adopted. In fact, it was because I looked into vaccines for so long and had like so much information that is scientific. I mean, we didn't even really talk about those graphs. I mean, like I said, all those diseases had already, you know, gone down so much. You said that, well, maybe it's a combination of things. Well, 95% of it was before the vaccine. And we credit all of that for the vaccine. It's ridiculous. And anyway, there's, you know, I could probably talk for 6 hours about things that we haven't even touched on when it comes to vaccines off the top of my head. And so it's not the same. It's because I was like had so much information when it comes to vaccines that, and then I would bring it to people and they, well, you know, at least we're talking about it, Max, but like usually you never even get this far, right? But to me, it's obvious, honestly. If you can break out of the idea that, you know, they're God's gift to humanity or whatever, like when you start to look at all these things critically, it becomes rather obvious, I think. And it just, I mean, and that's how I feel. I feel like this is basic stuff. And the fact that I was talking to Jaron about this, actually, I mentioned this to Jaron, that like it would actually help if more people could see this, what I consider obvious truth of like something like vaccines. Then we wouldn't be like, feel like we're gaslit. Because that's how I kind of feel like I'm gaslit sometimes. Like even with your audience, it's like, you are flat earther, that's retarded. You know, I mean, they didn't say that, but you know what I mean? And I can kind of admit that. Yeah, I guess it was in some ways. I mean, if you look at one of Flat Earth Dave's presentations, you know, it can be kind of compelling, but there's some basic stuff that I never should have got this far with Flat Earth. And it is kind of dumb, but it's just not the same. It's just not the same with the vaccines.
I think that is a little bit of you know, one retreating into the safety of our own beliefs as kind of like a safety net or a security blanket or so. But the way that you mentioned that there is evidence, there is way more evidence that the vaccines are effective. And I did acknowledge that, yes, in the case of polio, for example, sanitation helped a lot in reducing the cases of polio. Now, the vaccines made it almost like I have never seen anyone who's had polio in my country, and I live in like the third world. And I was checking some stats today. In Uruguay, there in the last 10 years, there's been 2 cases of measles. One was someone that traveled outside of the country, and the other case of measles was someone that came to Uruguay for vacation, got sick with measles, but then it didn't spread to anyone else because we have a very high rate of vaccination because healthcare is free here. So there is evidence for vaccines, and when you have a corpus of evidence, and then you have like one study that could potentially not be done correctly or that has contradictory results, what you do is you just do the study again. And it would have been maybe if you ever want to present more evidence, we can schedule that down the road. But the evidence is actually there. Max says for $5 Singaporean, the same kind of thinking that got you to flat Earth is getting you to these bad conclusions. How don't you see it? To us, the parallel is very clear. In the
I guess I mean, I feel like I responded to everything that you brought up, tried to present like why I don't believe things, and then I said, like, what was that guy's name?
Max.
His name's Max too. Okay.
Yeah.
Max, I mean, like, do you have an answer for why they couldn't infect the people in the Spanish flu? Do you understand that they thought that a bunch of diseases were, infectious when they weren't? Like, do you understand that, I know of many people who vaccinated their kid and had their kid regress into various illnesses and have extreme reactions. And in some cases, they do turn autistic. I don't believe that they are actually tested against placebo controls. There is no study showing totally vaccinated 80 times before the age of 18 versus no vaccines. And every time it is unofficially done through just gathering data and stuff, or like one doctor showing in his practice, you can see the chronic illness is higher in the vaccinated. I mean, what do you mean? It's not the same as flat Earth, dude. All of you people have the same kind of a belief that flat earthers have. You just don't see it. That's the problem. That's why it's good that we're having conversations like this. We got to get out of our echo chambers. Not everything is a conspiracy, but not everything science is correct on either. It's somewhere in the middle. And I could be wrong on vaccines. I might be wrong on illnesses being contagious. Like, that is a bit of a bigger leap to make. But again, even in my day-to-day life now, like, how often do I get sick from when my kids are sick or something, coughing into my face? Doesn't do anything. Like, what gets me sick is when I drink too much, don't get enough sleep, eat at restaurants a little bit too much, under stress, that's when I get sick. I didn't wash my hands or wear masks during COVID. Did I ever get COVID? No. Anyway, it's comments like that I'm like frustrated. I'm like, dude, you don't understand. Flat Earth is different. It is. It's a comforting idea that, everyone flat earthers are retarded. Look at it. He thinks of the flat Earth. Oh yeah. So vaccines, everything, all those other beliefs must be equally, based on nothing. No, it's not like that. That's why I became a flat earther, is because I went through 10 of these already, deeply studying them. Flat Earth, I was never even fully 100% like I know. Like, vaccines, I'm like way more versed in than I ever was flat Earth. Just saying.
All right. Who done it? I feel maybe it could be, what if statements you use often, why aren't you using more concrete statements that would imply knowledge instead of supposition?
Because I've gotten wiser, and I know that especially when it comes to these things, we need to be careful. I don't want to identify with being anti-vaxxer, or I mean, I don't really have a problem with that. I think I'm running a battery here. I might need to put in a battery soon at some point if we're gonna keep going. But
no, I'm about to. I have one more question, and we
okay,
can
cool.
wrap
We might
it
be
up.
good then. Sorry, I lost my train of thought there.
No problem. We can move on to the next one, Mr. Sir. I actually have two more questions. What is your method for doing research on this topic?
Initially, it was documentaries. Now, one of them was like a 12-part, 15 hours worth of documentary talking to scientists and doctors and all the things. Other documentaries, books, and then, debates, whatever. I will say that, most of what I did was look at those that are critical of vaccines. But the thing is, it doesn't take much to get the other side, right? I mean, we grew up with the other side believing all these things, and then you can't, you don't understand that, people are asking for true placebo studies and they're not produced. You can, I guess we have to have another video to get into these things, because
sure, I'm willing to take a look at them. And I mean, I can bring, a list of studies and meta studies, and then we can compare them. Sure.
Yeah. I actually think it'd be really good in all of these issues, climate change, flat earth, vaccines, whatever. It'd be cool to have everything just broken down in a logic tree or something. Let's figure out, here's the claim. There's 10 claims within vaccines are good for you. Okay, this one. Okay, what's the best argument on this side? What's the best argument on this side? For each point and then each sub point, we could really, and we're kind of just, we're laying the groundwork. We're superficially talking about our beliefs and stuff. But yeah, let's go look at the studies. Let's go, how do you explain these people who couldn't reproduce the Spanish flu in these prisoners using all these methods? How do you explain the doctor who tracked his patients for decades and can show you that the vaccinated kids are unhealthier? That's what I want to know.
What? Sure, I understand. But I mean, we can set it up and we can compare, studies by studies, because there is definitely studies about contagions and how they work. And finally, the last question from Basal Problems for $5. Do you believe in sunscreen?
No. I mean, I believe that the sun, you can get too much of the sun and it can burn you, and that's not good for you. But I don't know if, are you saying I'm I look sunburned or something, or wrinkly? I'm
no, I think
I'm red.
The tan. Yeah.
I'm tan, I'm red. This is a vintage lens I'm using. It's a little bit redder. I'm not actually sunburned. I do, I'm a little warm. You do
have a tan, right?
I'm tan and I'm flushed. I'm warm. I'm emotional a little bit, so I get a little red. But
I get it.
So I don't know if it was just a dig on how I look, or you're asking me if I believe.
No, because there is also a conspiracy that sunscreen is bad for you. And
yeah, I believe 100%. Yeah, I don't believe in sunscreen. You're correct.
Oh boy, I sunscreen is indispensable for me. I cannot. You see that I'm ghostly white, right?
Yeah, but that's because you're probably indoors all day long. So if you go out and get a bunch of sun exposure at once, you're going to burn. But if you were to gradually do it, you could build a tan like anybody. I mean, maybe not you've got lighter skin than I do, of course. Yeah, but
I don't get tanned. I'm white, I'm red burnt, and then I go back to white. I do not get tanned.
It might be true. It might just be that your whatever, your heritage, you're not really supposed to be at that close to the equator or something like that, But the idea that sunscreen, I mean, first of all, yeah, it's toxic too. I'm pretty sure that like I don't even know how you could argue that it's not at this point. Like they're purposely taking certain chemicals out of it because it is causing issues for people. And we need the sun. That's how we create vitamin D and all sorts of other hormones. Like there's a whole, like
No, I understand that part. The problem is that for me, I really cannot expose myself to the sun. I've been burned a handful of times, and it's impossible for me to go out to the sun.
Yeah.
In the summer, when I go 400 meters to the gas station, for example, and I wear very thin cotton hoodies, like an Arabian man mostly. I go with like the hood, and I guard myself from the sun because I will get red from walking 800 meters to the gas station and back.
Yeah, I understand. And look, like I'm sure there are some sunscreens that are not toxic, or you've been just using clay or whatever. I mean, I think that's fine, and I don't think burning is good for your skin.
Right.
So in some cases, maybe sunscreen it can be helpful, but like be very careful about what you're putting on your skin, and it goes for anything.
Mm-hmm.
Your skin just eats it up. It goes into your bloodstream. So most of the commercial sunscreens are toxic. Yeah, I believe that. All
right. Well, I want to thank you. It was I had fun. It was interesting.
Yeah, time flew. For
yeah,
me.
it goes by really fast. People in the audience, Nico, I will provide you the full, downloaded thing. So we solve the audio problems at the beginning.
I'll get better at this too. This is my first time.
No worries.
Streaming.
And we will schedule when Dr. J is available for you to talk to him about climate change and so on.
Yeah. Well, what do you think though, Max? Like maybe I do need to prepare a little bit more and actually bring some receipts or something. So then we have more to go off of.
Yep. But it's okay. It's all good. I knew kind of the framing for this. So I do thank you for the conversation. And I do love the topic because I love chemistry. So I do thank you for that. Anything else you would like to say?
Feel free to leave comments on either of our channels, questions, stuff that you'd like me to show or defend my position on or something, because I'll do that. Maybe we can have a follow-up in a month or something, and I'll come with a little bit more of the actual things that we could look at, or even send you them beforehand. So like,
right. Yeah, that I do kind of like that, so that we can
we got to get deeper into this stuff, I think,
sure.
for either of us to budge, because I don't think either of us really budged at all in this case. And not that we'll ever get there, but I actually think that we should be able to get there, honestly, to be honest. Like,
yeah,
is it crazy to think that like flat earth or something, like sooner, like there's got to be one or the other. We got to be able to figure it out, right? And yeah, flat earth, okay, I get it now. But with something like this,
we can definitely arrange to have a more in-depth discussion with evidence, and we can share it beforehand so we know what we're talking about, and keep it, let's say, to like a couple of papers, so that we can do a deep dive on those. I have no problem. This is a topic that I really enjoy talking about.
Yeah. Okay, cool. Let's do a follow-up then at some point.
Yeah, perfect. All right. Thank you so much. Looks like people voted yes for after show, so I'll set that up, guys. Nico, thank you so much. People in Nico's audience, thank you. And
Thanks,
we'll catch you on the next one. Take care. Have a great night. And I'll set up the after show in a couple of minutes. Bye-bye.
Bye-bye.